A black start is the procedure for restarting a power system that has completely died. No voltage anywhere on it, and no outside supply to draw on. It begins with a unit that can be brought up without one, a plant with, in the European wording, black start system capability. From there, the plan works outward along what the industry calls a cranking path. Energized transmission from that first machine to the auxiliaries of the next one, and the next, until enough of the system is alive to be joined together. Ontario's system operator publishes how long each kind is expected to take. 30 minutes for a hydro unit or an aeroderivative gas turbine, 60 for a frame-type gas turbine, 2.5 hours for a hot steam turbine. Those are figures from a manual. They are what a plan expects, not what anyone measured on a night when it mattered. Here is something somebody did measure. In 2018, the federal regulator and the North American Reliability Organization reviewed black start availability. One 13 kilovolt unit, they wrote, recognized during its own expanded testing that it could not energize a 230 to 69 kilovolt transformer in its cranking path. The unit could start. The path could not be energized. Two different capabilities, and only the first is what the phrase usually means. One more detail from that manual, because it sets the shape of what follows. A hydro black start unit often needs a supplemental diesel just to raise its head gates. A dam needs a diesel to open a gate to make electricity. Hold on to that, it is the last thing in this film. February 2021, Winter Storm Uri. At 1:51 in the morning on the 15th, frequency on the Texas grid fell below 59.4 Hz. That number is a relay setting. Below it, generator under frequency relays start a 9-minute timer. If frequency is still under the threshold when it runs out, those generators disconnect to protect their own machinery. Frequency stayed below 59.4 Hz for 4 minutes and 23 seconds. Its lowest point was 59.304 Hz at 1:54. Then it recovered and the timers reset. 9 minutes minus 4 minutes and 23 seconds is 4 minutes and 37 seconds. That is where the most repeated number from that night comes from. It is almost always quoted as elapsed time, a countdown that stopped with 4.5 minutes left. It is the opposite. It is the part of the fuse that did not burn. The federal review states the consequence directly. Had the under-frequency relays tripped, approximately 17,000 megawatts of generation would have been outaged, potentially causing a total blackout of the whole Texas footprint. The same report calls those hours the most dangerous 2 hours of the grid operator's existence. And the operator told a congressional committee in writing and under oath what the other side of that line looked like. Had a blackout not been stopped, power could have been out for 90% of Texans for weeks. So the question is not how close Texas came, it is what would have happened next. That 4-minute figure comes from the grid operator's own slide deck to Congress. Across 23 slides, that deck never uses the phrase black start once. This is what it did not discuss. 28 machines. That is the black start fleet the Texas grid operator had under contract in February 2021, 1,711 megawatts between them. All 28 used natural gas as their primary fuel. Not most, all, no diversity at all. At about 1:45 on the morning of the 15th, the worst moment of the event, 6 were unavailable. 6 out of 28 sound survivable. Measure the same fleet by capacity across the whole event, and it reads differently. 82% of that black start capacity, 1,418 megawatts of 1,711, suffered an outage, a derrit, or a failure to start. 39% are attributed to fuel limitations, 18% to freezing. One fleet measured 2 ways, 6 units out of 28, 82% of the megawatts. The federal reviewers wrote the conclusion themselves. Had a total blackout of the Texas system occurred during that time, the unavailability of black start resources would have hampered the operator's ability to promptly restore the system. 28 machines, all burning the same fuel, in a week when that fuel stopped arriving. The plan for the worst day was made out of the thing that was failing. There is a second half to a restoration plan, and in most cases here, it is the half that worked. If a neighboring system is still alive, you do not start from nothing. You bring voltage across the boundary, use it as a reference, and build outward. Texas cannot. The Federal Review says it flatly. The grid operator cannot rely on imports to restore its system in the event of a blackout. Its links to the rest of North America are direct current ties, totaling about 1,220 megawatts. Set that against the 17,000 megawatts that would have disconnected if those relay timers had run out. The way back in is about 1/14 the size of the whole. In 3 of the cases in this film, 2003, South Australia, Spain, what restored the system came from outside it. For Texas, that door is not there, which puts more weight on the written plan than anywhere else, and raises the obvious question: how fast is it supposed to work? There is no answer. The Texas operator's stated restoration objective, energize cranking paths, start next start units, synchronize islands, carries no time frame at all. There are deadlines for individual units. There is no clock for the system. In the same federal benchmark table sits Great Britain's grid operator. Restore 100% of Great Britain's electricity demand within 5 days, with an interim target of 60% of regional demand in 24 hours. 5 days is not a comfortable number, but it is a number, and somebody can be held to it. August 2003. The grid fails across Ontario and much of New York. 3 parts of the system never went down. At Wawa in northwestern Ontario, protective equipment separated the transmission system and kept electricity service running in the northwest. At Cornwall in the east, power continued to flow from Quebec, a system that operates separately from the eastern North American grid, through dedicated lines and from a local hydroelectric dam. And in the Niagara area, the system isolated itself, with the Sir Adam Beck hydroelectric station serving customers in Ontario and New York, and, in the Ontario operator's words, playing a critical role in re-energizing the system. Read that last one precisely because it is usually told backwards. Beck did not black start the system. Beck never stopped running. South of the border, the same thing happened, larger. One relatively large island remained in operation, serving about 5,700 megawatts of demand, mostly in western New York. That island, the reliability organization's own analysis says, formed the basis for restoration in both New York and Ontario. About 20% of New York's load never dropped at all. A fifth of the state stayed lit, and that fifth is what the rest was rebuilt from, over about 30 hours. And here is how the reliability organization explained why the restoration went well. One word does all the work. Fortunately, it wrote, the restoration was aided by the ability to energize transmission from neighboring systems, thereby speeding the recovery. Fortunately, in a formal recommendation. So read the official analysis of how that restoration was run. There is not one. The Reliability Organization's technical analysis, July 2004, says so on its 5th page. The restoration phase of the blackout was successful, it writes, and it has deferred the bulk of the analysis of system restoration efforts to the regions, to the regional transmission organizations, and to the operating entities. Then a promise. The results of this analysis will be consolidated and reported at a future date. There is no evidence it was ever published. It is absent from the organization's own search index, and the technical analysis has no restoration chapter, 22 passing mentions across 125 pages. The one-year stocktake, August 2004, contains 0 occurrences of the words restoration or black start, not a thin treatment, none. 3 regional bodies did prepare reports. None of the 3 is publicly locatable today, and 2 of those bodies no longer exist. The recommendation that asked for the work was closed regardless. The implementation report of September 2006 carries the line. Action required to fully implement Recommendation 29. No further action needed. Nothing here supports calling that a cover-up, and this film does not. The report may have been written and lost. The defensible statement is narrower. It cannot be found. But the consequence is concrete. 6 documents about that blackout were checked for this film, including both task force reports and the Ontario operator's own retrospective. Not one of them names a single black start unit or describes a single cranking path. September 2017. Hurricane Maria leaves Puerto Rico with no functioning power system. The number everyone remembers is 11 months. 100% of peak load restored on the 15th of August, 2018. The restart itself took 5 days. A Federal Energy Department situation report. As of Monday the 25th, the Central San Juan and Palo Seco generation units are operating, allowing the utility to energize transmission serving parts of Bay Amon and Montecillos. Day 5 after landfall. 2 North Coast plants cranking outward, physically a black start in all but name. The phrase itself appears nowhere in the federal reports on the recovery. So why 11 months? Not generation. Before the storm, the island had about 6,000 megawatts of capacity against a peak demand of about 3,000, 100% reserve margin. Generation was damaged. Palo Seco badly enough that the working group recommended replacing most of its units. But generation was never the binding constraint. The wires were. About 70% of the island's generation sits in the south, and 70% of its demand in the north. Between them run mountain corridors that suffered catastrophic failure. Only 15% of the transmission system was built for a Category 4 or 5 storm, and 252 of the utility's 334 substations were damaged. Twice the curve ran backwards, and both times a wire did it. The 13th of October, approximately 9% of normal peak load has been restored, down from 17% yesterday, due to a transmission line fault that tripped the San Juan plant. And again in November, when a 230 kilovolt fault knocked it from past 50% back to 46.6%. The 28th of April, 2025. 100% of demand on the Spanish Peninsula is lost, and all of Portugal's. Why it happened is a different film. This one starts with a dead grid and a list of plants obliged to start themselves. There were 12 black start attempts in Spain that afternoon. 5 held, the first island up at 11 minutes past 2, the last at 1 minute past 3. 4 came up and then lost it, the last holding until 16 minutes past 7 that evening. And 3 never established one. The Madrid and Toledo area tried 5 successive times and failed 5 times. Andalusia failed twice. The Spanish government's committee wrote it plainly. Several installations with an obligation to start autonomously ultimately could not deliver that service stably, joining the system only once voltage had arrived from outside. That last clause is the whole story. The restoration was based on 3 main islands, Catalonia and the Basque Country with support from France, and the south with support from Morocco. The prompt supply of voltage and energy from France and Morocco, the committee writes, allowed the first islands to be raised, islands from which the combined cycle plant's auxiliaries could be fed. As energy it was small, France peaked at about 1,685 megawatts and was down to 80 by the end, and Morocco was capped at 100. As a reference, it was decisive. One more thing, not incidental. In the Spanish committee's non-confidential report, The plant-by-plant account of which obligated plants failed is pages 124 and 125. Those 2 pages are blank. Portugal is the counterweight, and it is owed. The Portuguese operator restored the national transmission network from the 2 power plants with black start capability in Portugal, working bottom-up. The Spanish operator, the European panel's factual report records, could provide no support during the first hours. That is not a figure of speech. The interconnection capacity between Portugal and Spain was set at 0 megawatts in both directions. What crossed that border was a frequency reference, not energy. Portugal's regulator names the 2 plants, which is unusual enough to note. Castelo de Bode, hydroelectric, Tapada do Alteiro, gas combined cycle. And it went badly before it went well. At 12:45, Castelo de Bode enters black start mode. At 12:49, it trips, taking out its own auxiliaries. Repeated restarts fail because the small hydro units feeding those auxiliaries will not start. Meanwhile, Tapada do Alteiro cannot close its generator circuit breaker for hours. Problems in its control and command system. At 20:04 in the afternoon, Castelo de Bode restarts. 15 minutes later, it trips again. It is stable only at 13 minutes past 4. Tapada do Alteiro starts at 22 minutes to 5, trips at 26 minutes past 5, and is restarted in the same minute. The Spanish transmission system was fully restored within 16 hours. The Portuguese system within 12. No outside energy. 2 failed attempts on the way, and 4 hours sooner than the neighbor that had a voltage reference from 2 other countries. That is what the procedure looks like when it works. It fell over twice before it held. Argentina, the 16th of June, 2019. The system collapses at 6 minutes past 7 in the morning. Full restoration comes at 9:35 that night, 14 hours and 29 minutes. A study for the national regulator went through the restoration machine by machine. 18 units had black start problems. 2 large hydro plants carried it, Yacyretá and Salto Grande, which drove the recovery of Greater Buenos Aires with no recorded incident. Even they were not clean. Yacyretá dropped out 3 times, costing about 46 minutes. At the Alto Val thermal plant, nothing started at all. The recorded reason is insufficient battery voltage. Then El Chacon, a hydro plant with black start capability on the 500 kilovolt network. From 14 minutes past 8, it failed repeatedly, breaker bounce, protection operations. The report's sentence is this: only at 5 o'clock in the afternoon, when the 500 kilovolt bus bars were energized from outside, could a machine be put into service. Energized from outside. A plant meant to be a starting point had to be started by the network it was there to start. The study concludes that El Chacon and Planicie Bandeirita are why the 500 kilovolt network could not be energized outward toward Buenos Aires. It had to be done, in the report's words, al revés, backwards, from Buenos Aires to Comahue. A footnote: a national resolution of 1998 required black start and islanding capability within 720 days. Compliance appears never to have been verified, and Uruguay was not simply dragged down alongside Argentina. It sat in the surplus half of the split, tripping on overfrequency, and collapsed on underfrequency only when the last ties opened. South Australia, the 28th of September, 2016. The state's entire power system goes down. It had 2 contracted black start services, both successfully tested less than 6 months before, in April and May. Both failed on the night. At Mintaro, the emergency diesel generator tripped after only 5 seconds of operation, due to a stator earth fault, which severely damaged the diesel generator. Quarantine is the reason this film exists. At Quarantine, the procedure involves a small generating unit, 2 larger ones, and 3 circuit breakers connecting 2 bus bars. The order those breakers close in is the procedure. In the tests, the 3 breakers were already closed before the small generating unit was started. On the night, the procedure connected the 2 generating units after the smaller was already operating at nominal voltage. Closing them at that point essentially resulted in a large inrush current on the larger unit's transformers. Same plant, same equipment, same people, 2 written procedures differing in the order of 1 step. The market operators report records what nobody had noticed. Although it had a copy of both procedures, neither the generator's staff nor its own were aware the procedures were subtly different. The test that passed was not a test of the procedure that would be used. The cost, in the same report, clearance to restart the Torrens Island generating units would likely have been given approximately 1 hour earlier. What actually brought the state back was the Haywood interconnector from Victoria. The restart service's auxiliary supply was not completed before supply to the Torrens Island area arrived over it. 2 contracted services, 2 passed tests, neither one used. Failures like that are how engineering learns. The North American Reliability Organization publishes them, short documents called Lessons Learned, each describing something that went wrong on a real system. That library was enumerated for this film and searched in full. 213 documents from 2010 to 2026. Not one title contains the word black or black start. Exactly 1 document out of 213 mentions black start at all, and only as a forward-looking recommendation. 16 years of publishing what went wrong, and a failed black start test has never once been the subject of one. That is not because the tests pass. In December 2023, the federal regulator and the Reliability Organization published a study of black start availability in Texas, where 4 mandatory tests are required before annual certification. Their finding: defects in the black start sources were found every year, and tests rarely passed first time. So the results exist. 7 bodies were searched for any published aggregate of black start test failure rates: the Reliability Organization, the federal regulator, and 5 system operators. No such public dataset appears to exist. The closest thing to an exception in this film is 1 sentence in a federal report about an unnamed 13 kilovolt unit that found during its own testing that it could not energize a transformer in its cranking path. 1 sentence against a study that says defects were found every year. The absence is the finding. A modern answer gets the same test. The Reliability Organization's white paper on grid forming technology says such inverters can be designed as an initial black start resource. 3 cases are cited as proof. First, the Imperial Irrigation District in California. The white paper dates its battery's black start to 2016. That is the commissioning year. The event was the 10th of May, 2017, when the battery started a 44 megawatt combined cycle gas turbine. A real event, and the thinnest paper trail here. The white paper's source is a trade press article now dead, and the State Energy Commission documents the asset without mentioning black start. Second, Dalrymple in South Australia, listed in the same paper as demonstrating black start capability, with no date, no megawatt figure, no description of what was energized. What is documented is 2 33 kilovolt feeders and about 3 megawatts of demand. And Dalrymple's real events are islanding transitions, not black starts. The grid is live, the connection is lost, and customers never see 0 volts. Australia's market operator states the limit. Energization at a bulk power system level has not yet been demonstrated. Third, Dursalock in Scotland, 2020, a genuine world first and smaller than reported. 69 megawatts is the site rating. The grid-forming algorithm ran on 4 turbine converters, roughly 12 megawatts, self-started off external diesel generators. The island held 7 minutes. On a network deliberately switched out for the trial, staff posted along the line. None of that means a battery cannot do this. The same white paper lists control strategies for Black Start as an open research need. The claim is not that the technology fails. It is that the reputation runs well ahead of the published evidence. Ontario publishes what a tested Black Start capability looks like. Market Manual 7, Part 7.8, December 2024. Certified facilities are procured as an ancillary service, ideally one in each of 4 electrical areas. And each certified unit must complete at least 3 Black Starts in 8 hours. 3, not 1. The manual gives its own reason. Due to the transience in an island, there is a possibility of recollapse during a real event, so this capability is essential. Read that as a budget. It assumes the first attempt may not hold and the second may not either. The plan for the worst day expects to fail twice. The manual names no facility. Neither does the European panel's report nor the Spanish committee's. The substations are public. The plants that failed are not. What it does record is the smallest machine in the film. A hydro Black Start unit often needs a supplemental diesel just to raise its head gates. Tested monthly. 5 systems in this film went completely dark. 3 came back on something that never went down. Argentina came back on 2 plants that held, and a third fed backwards. In Portugal, and only in Portugal, the plan did it alone at the 3rd attempt. Texas never had to find out. On its closest night, 82% of that fleet was out, and no neighbor to borrow from. Every number in this film was published by the institution being measured. What is missing is the evidence in between, the tests. The plan for the worst day is the one plan nobody is allowed to see fail. A dam and a diesel.